morning session online. Those who are attended, it is easy for you. Those who are not attended, listen that morning session, that lecture also, the 3-hour session, very important. System of linear equations, 2 marks. Eigenvalues, eigenvectors also very important. These two sessions are completed. Yeah. This is clear now. Let us go to next question. Is it clear? Chapana, any confusion? Understood. Let us move to our next question. Next question. For the matrix 4 3, for the matrix 4 3 3 4, if 1 1 is eigenvector, then corresponding eigenvalue is what? For the matrix 4 3 3 4, if 1 1 is the eigenvector, then corresponding eigenvalue. What is the corresponding eigenvalue? For the matrix 4 3 3 4, 1 1 is the eigenvalue, corresponding eigenvector. What is the answer? How to find corresponding? Ax is equals to lambda x. This equation is there. Ax equal to lambda x. If ax is equals to lambda x, a square x is equals to lambda square x. A cube x also lambda cube x. A power of nx is equals to lambda power of nx. All of you know, if lambda is the eigenvalue of the a, lambda power of n is eigenvalue of a power of n. If x is eigenvector of the a, x is also eigenvector of a power of n. All these properties very important. X is equals to lambda x. Observe here. 4 3 3 4 into x. What is x here? 1 1. Ax is equals to lambda x. Is asking what lambda value, corresponding eigenvalue. What is lambda value is asking. What is the answer? Corresponding eigenvalue, lambda. Can you guess what is the answer? If you multiply them, what is that? 4 plus 3, 7. 7 is equals to lambda 1 1. 7 bring outside 1 1 is equals to lambda 1 1. How much is the lambda value is equals to? 7 is the answer. Lambda value is equals to 7. All of you understanding what is the property? We are using formula. See, one matrix is eigenvector is given. One matrix eigenvector is given. How to calculate eigenvalue? Using the formula Ax is equals to lambda x. Very, very important formula. So many get questions on the Ax is equals to lambda x formula. How much is the lambda value here? 7. Anybody confusion in this? Please clear. Last one is clear now. Yeah. Next question. 1 2 3. If 1 2 3, the value of p, the value of the p such that vector 1 2 3 is eigenvector of 4 1 2, p 2 1, 14 minus 4 10. All of you, the value of the p such that vector is eigenvector of the, you can try 2 minutes time, tell me what is the answer. What is the formula we have to use? Ax is equals to lambda x. Try చేయండి. సీరియస్గా వర్కౌట్ చేయండి. గేట్ ఫస్ట్ టైము సెకండ్ థర్డ్ అటెంప్ట్ ఎక్కడో ఒక దగ్గర మనకి గేట్ తగులుతుంది. ట్రై చేయడం అనేది ఆపొద్దు. ట్రై అటెంప్ట్స్ ఏంటంటే ఒక అటెంప్ట్ చేసేసి వదిలిపెడతారు. యూ కెన్ గో సెకండ్ ఆల్సో, నో ప్రాబ్లం. వాట్ ఇస్ ద ఆన్సర్ హియర్? The value of the p such that vector 1, 2, 3 is the eigenvector of the matrix. Anybody answer? What is the property we are applying here? Ax is equals to lambda x. Ax is equals to lambda x. 412 p21 14 minus 410 Ax is equals to lambda x. Multiply them. 4 plus 2, 6. It's a 12. P plus 7. 14 minus 8 plus, this is what? 14 minus 8. 6, 30. 36. 12. P plus 7, 36 is equals to lambda, 2 lambda, 3 lambda. Question what the question is asking? P value is what? P value is asking. What is the value of the P? Lambda is equals to what? 12. Lambda equal to 12. P plus 7 is equals to 24. P plus 7 is what? 2 lambda. P plus 7 is 2 lambda. P plus 7 is equals to 24. P is equals to what answer? 17 is the answer. P is equals to 17. Everyone understanding? P is equals to 17. What is the formula applied here? Ax equal to lambda x. Ax is equals to lambda x. Yeah, coming to next. బాబు సీరియస్నెస్ మెయింటైన్ చేయండి. హలో, yeah, next question. Yes. Try this question. Try this. If A is a 3 by 3 matrix, A is a 3 by 3 matrix. A is a 3 by 3 matrix. Has eigenvalues 1, 2 and 5. A is a 3 by 3 matrix, has eigenvalues 1, 2 and 5. What is the determinant value? What is the answer? If you know the eigenvalues, what is the determinant value? Determinant is equals to what is the value? Product of the eigenvalues. బాబు ఉన్నదే కొంతమంది జర డీసెంట్ మెయింటైన్ చేయండి అట్మాస్ఫియర్. ఒక 500-400 క్రౌడ్ కూడా చెప్పింది జరిగింది. డీసెంట్ అట్మాస్ఫియర్ మెయింటైన్ చేయండి. నేను 2-3 సార్లు మళ్ళీ పదే పదే చెప్పాను. కరెక్ట్, రైట్. What is the answer? If A is a 3 by 3 matrix has eigenvalues 1, 2 and 5, what is the determinant value? Determinant is equals to product of eigenvalues. Product of eigenvalues. 1 into 2 into 5, 10 is the answer. Straight bit. Product of the eigenvalues. 1 into 2 into 5. 1 into 2 into 5, 10 is the answer. Next. What is this answer? 18th bit. Product of the eigenvalues. What is its answer? Product of the eigenvalues. Direct answer. What is the answer? Product of the eigenvalues is? Product of eigenvalues is the determinant. Determinant. What is the determinant of this? 2 into 7, 14. 14 is the answer. 2 into 7, 14. Yes. Yeah, coming to next question. Four, 8, 4, 8, 16 minus 4. X is the eigenvector 2, 1, 4. R is the 32, 16, 64. The eigenvalue is, what is the eigenvalue? Yes, try this one. What is the eigenvalue? The matrix equation. Hello, what is the matrix equation is given? Ax equal to R. Can anybody guess what is the answer? Ax is equals to R. Ax is equals to R. Yeah, what is Ax is equals to R value is what? Ax is equals to R is what? 32, 16, 64. We can bring this Ax into Rx. R means what? Lambda x. What term we can bring outside common? Common em diyachama bayatiki? 16 is the common. 16 into 214. Then now it is in the form of, what is the formula? X is equals to lambda x. X is equals to lambda x. How much is the lambda value is? 16 is the answer. ఈ ఐడియా రావాలమ్మా మనకి. ఇప్పుడు ఏఎక్స్ని మల్టిప్లై చేస్తే అదంతా చేయొద్దు మనం. జస్ట్ వీ షుడ్ గెట్ దిస్ ఐడియా. ఏఎక్స్ ఇజ్ ఈక్వల్స్ టు లాంబ్డా ఎక్స్. మనం r ని ఎలా రాస్తున్నాం? We are expressing r in the form of lambda x. Ax is equals to lambda x is the correct answer. Yes. All of you try this question. What is the answer? Number of distinct eigenvalues. How many distinct eigenvalues of the matrix we are having? Number of distinct. What are the eigenvalues of this one? Eigenvalues are 1, 1, 1. How many distinct eigenvalues we have? Only one distinct eigenvalue. Different ఏమని మనకి ఒకటే ఉంది కదా, ఎక్స్ట్రా ఏమైనా ఉన్నదా? లేదుగా. వాట్ ఇస్ యువర్ ఆన్సర్? సి ఆప్షన్. సి ఆప్షన్ 1 is the correct answer. సి ఆప్షన్. 4 to 2, 4 matrix A, eigenvector is 101, 101. What is its eigenvalue? Try. Matrix A is given, eigenvector is given. What is eigenvalue? Try చేయండి అమ్మ అందరూ. Try all of you. A is 4 to 2, 4. X is 101, 101. What is the eigenvalue? Lambda. What is the logic? Ax equal to lambda x. Ax is equals to lambda x. 4 to 2, 4. 101, 101 equal to lambda into 101, 101. Multiplying them, what is the result? You will get 606, 606, 606, 606, 101, 101. Can you guess what is the lambda value? 6 is the answer. Lambda value is what? 6. You can take the 6 here. You can take 6 common. 101, 101, 6 lambda into 101, 101. Lambda is equals to 6 is the correct answer. Lambda equal to 6. When matrix is given, eigenvector is given, how to calculate eigenvalue? Ax is equals to lambda x. The number of distinct eigenvalues. The number of distinct of the matrix. Hello, what is the answer? Number of distinct eigenvalues of the matrix. What is the answer? How many distinct eigenvalues are there? Now concentrate. How many distinct eigenvalues are there? 3. What are the eigenvalues we are having here? 2, 1, 3, 2. How many different eigenvalues are there? 2 repeated 2 times. 1, 2, 3. How many distinct eigenvalues? 3 is the correct answer. 3 different eigenvalues. Total we have 3 different eigenvalues. 3 different eigenvalues. What type of matrix it is called? What type of matrix it is? Upper triangular matrix. Yes or no? Upper triangular or lower triangular? Upper triangular. What are the eigenvalues of the triangular matrix? Principal diagonal elements. What are the eigenvalues of the triangular matrix? Principal diagonal elements 2, 1, 3, 2. Upper triangular, lower triangular, diagonal, scalar. What are the eigenvalues? Principal diagonal elements. Next. It's 2 and 3, 4 and 9. It's 2 minus 2 and minus 3. Now you can guess the answer. What is the answer? What is the answer? If eigenvalues of A are lambda, eigenvalues of A lambda, A square eigenvalue is what? A square eigenvalue is lambda square. As per this knowledge, if eigenvalues 4 and 9 are the eigenvalues, what are the eigenvalues of M square? What is the answer? 16 and 81. Direct answer. 16 and 81. Simple question. 16 and 81. Straight away. 16 and 81. Using the property. 16 and 81. 16 and 81 is the correct answer. Yeah, coming to next. U is 1, 2 matrix. V is 1, 1 matrix. U is 1, 2. Consider the matrix A is equals to what? U, V transpose. U is 1, 2. V is 1, 1. U is 1, 2. V is 1, 1. What the question is asking? V transpose means what? All of you know transpose of the matrix V. Largest eigenvalue of the matrix A. What is the largest eigenvalue of the matrix A? Anybody try? A is equals to what? U into V transpose. A is equals to U V transpose. A is equals to U. This is U matrix. What is the V transpose? 1, 1. U V transpose. A is U V transpose. What is its multiplication here? 1, 1. Right. 1, 1, 2, 2. See what type of matrix it is. 1, 1, 2, 2. What type of matrix it is? Is it singular matrix or not? Hello. Is it singular matrix or not? Singular matrix means what? Determinant value? 0. What is the determinant value of this? 0 or not? How this determinant value 0? Two rows are what here? Two rows are proportional. If two rows are the same, two rows are proportional. What is the determinant value? 0. This determinant value 0. Determinant value 0 means what? One of the eigenvalue must be 0. Determinant value 0 means one of the eigenvalue is 0. So total how many eigenvalues are possible here? Total eigenvalues. Eigenvalues ఎన్ని వస్తాయి మనకి ఇక్కడ 2 eigenvalues కదా. Because of 2 by 2 matrix you will get the 2 eigenvalues lambda 1 and lambda 2. One eigenvalue is already 0. What is another eigenvalue? Lambda 1 plus lambda 2. Sum of the eigenvalues, what is the property? Trace. Sum of the eigenvalues is a trace. Yes or no? Sum of the eigenvalues is a trace. 1 plus 2, 1 plus 2, 3. One eigenvalue is 0 already, lambda 2. What is the largest eigenvalue here? Largest eigenvalue is what? 3 is the answer. Largest eigenvalue of the matrix A is 3. First of all, what you confirmed? What did you confirm? It is what type of matrix? Singular matrix. Since it is singular matrix, one of the eigenvalue it must be 0. The other eigenvalue, how we are getting the other eigenvalue? Using sum of the eigenvalues is the trace, using that property. Next. Yes. Consider the matrix A. Matrix A is 50. This is 50, 70, 70, 80. Whose eigenvector corresponding to eigenvalue lambda 1, lambda 2, 70 and lambda 1 minus 50, lambda 2 minus 80, 72 respectively. Then the value of x1 transpose into x2. What is x1 transpose into x2? See, we have properties of eigenvalues and eigenvectors. Eigenvectors of symmetric matrix. Eigenvectors of symmetric matrix. Very important. Eigenvectors of symmetric matrix are orthogonal. Eigenvectors of symmetric matrix are orthogonal. Yes, check this one. Is this symmetric matrix or not? 50, 70, 70, 80. 50, 70, 70, 80. Is it orthogonal matrix? Symmetric or not? Symmetric. What is the condition for the symmetric matrix? A transpose equal to. What is A transpose here? 50, 70, 70, 80. A transpose equal to A. Symmetric or not? Symmetric. Morning property చెప్పాను ఒకసారి చూడండి మార్నింగ్ ప్రాపర్టీస్ లో. What are the eigenvectors of symmetric matrix are what? Orthogonal. Using that, straight away, what is the x1 transpose into x2? You can write answer 0. Answer 0. Orthogonal. x1 orthogonal matrix different, orthogonal vectors different. Orthogonal matrix condition is what? Orthogonal matrix A transpose A equal to I. A into A transpose equal to I. These are the orthogonal matrix. What are the properties of orthogonal matrix? Determinant plus or minus 1. A inverse is A transpose. That is different. Orthogonal matrix condition property is different. Orthogonal vector is different. What is x1 transpose x2 equal to 0? Which matrix eigenvectors are orthogonal? Once again remember, which matrix eigenvectors are orthogonal? Symmetric matrix eigenvectors are orthogonal. This is x1 is given. x1 transpose x2. x1 transpose 70 lambda 1 minus 50. x1 transpose into x2. Lambda If you take this one product, already మన answer confirm చేసినామమ్మా. What is the property? Using the property we confirmed answer is what? 0. And also we are checking like this. What is the multiplication of these two? 70 into lambda 2 minus 80 plus this is what? 70 into lambda 1 minus 50. What is the common in both of them? 70 is common. 70 is common. Lambda 2 plus lambda 1 minus 80 minus 50. What is the lambda 1 plus lambda 2? Sum of the eigenvalues is what to trace? What is the lambda 1 plus lambda 2 is 130. 130. 130 minus 130 is equals to 0. This is second approach. మనకి ఏది ఈజీ ఉందమ్మా, ఫస్ట్ ఆర్ సెకండ్? విచ్ అప్రోచ్ ఈజ్ ఈజీ, ఫస్ట్ ఆర్ సెకండ్? First one is easy. First one is what? If you remember property, then first one is easy. What is that? Eigenvectors of symmetric matrix are orthogonal using this property also. Yeah, coming to next. ఇక్కడ మీకు two solutions discuss చేశాము. Both the solutions are cleared. Both the approach. Coming to next. What is the answer? Try all of you. Easy bit. 5 seconds enough to answer. If you have knowledge about the eigenvalues and eigenvectors properties, 5 seconds enough to answer it. Okay. Half minute time I will give it to you. Tell me what is the answer. చెప్పండి అమ్మా, ఏంటి ఆన్సర్? ఏం అడిగిన క్వశ్చన్ చూడండి. వాట్ ద క్వశ్చన్ ఈజ్ ఆస్కింగ్? 5. Some of you are saying 5. What is the property? The determinant of A. Determinant. This is a determinant of 2 by 2 matrix is 2 by 2 matrix. Determinant is 50. How many eigenvalues for the 2 by 2 matrix? 2 eigenvalues. Determinant is equals to what? Product of the eigenvalue. One eigenvalue is given what? 10. One eigenvalue is given 10. What is another eigenvalue? 50 by 10. ఈ క్వశ్చన్ మీకు గేట్లో వస్తే మాత్రం 5 సెకండ్స్లో ఆన్సర్ చేయాలి. అంత ప్రాక్టీస్ ఉండాలి. వెరీ సింపుల్ క్వశ్చన్. 5 సెకండ్స్. చాలా కొంచెం స్పీడ్ పెంచాలమ్మా ఎగ్జామ్లో. స్పీడ్ అండ్ అక్యురసీ బోత్. ఈ క్వశ్చన్ ఎగ్జామ్లో వస్తే 5 సెకండ్స్ కంటే ఎక్కువ టైం పట్టదు మీకు. బట్ వీ షుడ్ హ్యావ్ నాలెడ్జ్ కంప్లీట్లీ ఆన్ ఐగన్ వాల్యూస్ అండ్ ఐగన్ వెక్టర్స్, పర్ఫెక్ట్ నాలెడ్జ్. It is given that consider a 5 by 5 matrix. It is given that A has only one non-zero eigenvalue. Only one non-zero real eigenvalue. Only one non-zero real eigenvalue. A has only one non-zero real eigenvalue. What is that real eigenvalue is asking? Only one non-zero real eigenvalue. 25, 15. Yeah. Anybody answer? Only one non-zero real eigenvalue. A has only one non-zero. అంటే non-zero real eigenvalue 1 means what about the remaining 5 complex roots? Remaining 5 will be complex conjugates. Okay. What is our another one real eigenvalue is what? Real eigenvalue is what? Determinant of A minus lambda equal to 0. Determinant of A minus lambda. Eigenvalue definition is what? What is the eigenvalue definition? It is the root of the characteristic equation. Root of the characteristic equation. Determinant of A minus lambda I 1 minus lambda 2, 3, 4, 5. 5, 1 minus lambda 2, 3, 4. 4, 5, 1 minus lambda 2, 3. 3, 4, 5, 1 minus lambda 2. 2, 3, 4, 5, 1 minus lambda. Det is equals to 0. Det equal to 0. ఒకవేళ అడిగితే ఇట్లాంటిది 2 marks. Sometimes 2 marks possibility is there. Yeah. Now here we have to take the operation. C1 implies C1 modification. C1 plus C2 plus C3 plus C4 plus C5. Using this operation. So we are using this operation. Using this operation, tell me what happens here. If you are using this operation, చెప్పండమ్మా ఏ modification చెప్పండి. First column we are modifying. First column changes to what? 1 minus lambda plus 2 plus 3 plus 4 plus 5. 15 minus lambda. This is also a 15 minus lambda. 15 minus lambda. 15 minus lambda. 15 minus lambda. Remaining elements are as it is. Remaining elements, don't worry. They are all remaining, all elements are as it is. First column only we are modifying. Okay. Using our determinant property. Determinant properties మనము ఒక 14, 15 చెప్పాను. Yesterday I discussed determinant properties 14, 15. All properties are very important. Determinant of KA1, B1, C1. KA2, B2, C2. KA3, B3, C3. This property is there. What is the determinant of this one? You can bring the K outside. A1, B1, C1. A2, B2, C2. A3, B3, C3. Yesterday I discussed this property also. If any row column multiplied by the same constant in the determinant, entire that constant you can bring outside. Now which constant you can bring outside? Tell me here. 15 minus lambda outside. Yes or no? 15 minus lambda you can bring outside. Then what happens here? 1, 1, 1, 1, 1. Rest of the elements as it is. This we are equating to 0. 15 minus lambda equal to 0. What is the lambda value? 15 is the answer. Lambda value 15. What the question is asking? This matrix has only one non-zero real eigenvalue. What is the real eigenvalue non-zero? Lambda is equals to 15 is the correct answer. So, అంతేగాని మనము 15 minus lambda determinant characteristic matrix, if you are expanding determinant, it takes time. 5 by 5 determinant expansion easy అవుతుందా? అవ్వాలి, చాలా టైం పడుతుంది. 3 by 3 determinant is okay. 5 by 5 takes lot of time. This idea is required to answer it. Is it clear to all of you? What is the answer? Lambda equal to 15. అర్థమైంది కదమ్మా? What you have done? C1 plus C2 plus C3 plus C4 plus C5. Next, the eigenvalues of the matrix. Eigenvalues of the matrix. What are the eigenvalues of the matrix? Can you guess what are the eigenvalues of the matrix? Correct answer. What are the eigenvalues of the matrix? What is the property? Sum of the eigenvalues is trace. Yes or no? Properties. మార్నింగ్ లైవ్ సెషన్ వినే ఉంటారు, వినకపోతే ఖచ్చితంగా చూడండి ఒకసారి. What is the trace of this? Trace is how much? Trace is -4. Which sum of the eigenvalues is the -4? Option A is the correct answer straight away. Sum of the eigenvalues is the trace. Trace entama? -4. Which sum of the eigenvalues is -4? Option A is the answer. What is the property we are using? Sum of the eigenvalues is trace. Sum of eigenvalues is equals to trace is the answer. Sum of the eigenvalues is the trace. Yes. Determinant of, this is asking what? Determinant of A inverse transpose. Question is determinant of A inverse transpose. Can you guess what is the determinant of A inverse? Eigenvalues are given. If eigenvalues are given, what is the determinant of A? Determinant of A is what? Product of eigenvalues. How much is the determinant of A here? Determinant of A. Determinant of A is 1 into 2 into 4, 8. Determinant of A is 8. But is not asking determinant of A. What the question is asking? Determinant of A inverse transpose. Determinant of A inverse transpose. This is our question. What is the determinant of A transpose? Property. Determinant of A transpose is determinant of A? Yes or no? Determinant of A transpose is determinant of A? Determinant of AB is equals to what? Determinant of A into determinant of B. Determinant of A inverse is 1 by determinant of A. Determinant of Ka is k power of n into determinant of A, where k is the constant, k is the constant, k is the constant, n is the order of the matrix, n is the order of the matrix. Understanding? What is the formula? First, which formula you have to apply? Determinant of A transpose. This property we are applying. What is the determinant of A transpose? This is equals to determinant of A inverse. Determinant of, in place of A, what is the matrix we have? A inverse. చూడండి, determinant of A inverse. What is the determinant of A inverse is equals to 1 by determinant of A. Determinant of A, what is the answer here? 1 by 8 is the answer. 1 by 8. These determinant properties, we should have knowledge about all the determinant properties. ఒక 13-14 వరకు అన్ని ప్రాపర్టీ చెప్పాము, చదవండి డిటర్మినెంట్ ప్రాపర్టీస్. Determinant of A inverse, determinant of A whole inverse. It's clear, na? No confusion. What is the answer? You can guess the answer. What is the answer? What is the answer? Think about that. Hello. A is a 3 by 3 matrix. 3 by 3 matrix. Matrix A is the 3 by 3. All elements being what? 1 1 1 1 1 1 1 1 1. Every element is 1 1 1 1 1 1 1 1 1. What is the non-zero eigenvalue of this? Only one non-zero eigenvalue is what? Non-zero eigenvalue is what? Hmm? 0 0 3. 0 0 3 is the non-zero. 3 is the non-zero eigenvalue. What is the answer? Only non-zero eigenvalue 3 is the answer. What are the eigenvalues of this one? 0 0 3. It's not 1 1 1. 0 0 3 are the eigenvalues. Morning session also we have discussed this question. The options are given like 1, 1, 1. Another option is given 0, 0, 3. Like that some options are given 0, 1, 2. Like that different options are given. What are the eigenvalues of 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 3? 0, 0, 3 are the eigenvalues. Only non-zero eigenvalue is what? What is the non-zero eigenvalue? 3 is the correct answer. 3 is the correct answer. If you take the 2, 2, 2, 2, 2, 2 and 2, 2, 2, what is the non-zero eigenvalue of this? Non-zero eigenvalue is what? 6. Yes or no? 6 is a non-zero eigenvalue. See here, then very important point. 1, 1, 1, 1, 1 and so on 1. 1, 1, 1, so on 1. Like that 1, 1, 1, 1, 1. 100 by 100. 100 by 100 matrix. What is non-zero eigenvalue of this? Non-zero eigenvalue is what? 100? 100. Non-zero eigenvalue is 100. 100 or 1? 100. How many zero eigenvalues are available? Hello. It is a 100 by 100, 1 by 1. All are 1 by 1, 1, 1, 1, 1. How many zero eigenvalues? Total how many eigenvalues are possible? 100 eigenvalues. 100 eigenvalues. One eigenvalue is 100. What about the remaining all eigenvalues? 99. They are all zero eigenvalues. Zero eigenvalues. Understanding? If it is a 5 by 5, understanding one more. 5 by 5. All entries are 2, 2, 2. 5 by 5. All entries are 2, 2, 2. What is the non-zero eigenvalue? All entries are 2, 2, 2, 2, 2, 2. 5 by 5. You are not responding. 10. 10. Remaining are what? Zero eigenvalue. Remaining means what? 4. 4 are the zero eigenvalues. Try to understand the logic. Simple logic only, right? Yeah. Coming to next. Yeah. This one. 4, 2, 1, 3. 4, 2, 1, 3. Lowest eigenvalue. Lowest eigenvalue of. What is the lowest eigenvalue of? Lowest eigenvalue of 4213. What is the answer? Lowest eigenvalue of 4213. Can you guess what is the lowest eigenvalue of 4213? ఇక్కడ చాలా మంది ఏం చేస్తారంటే ఐగన్ వాల్యూ అనగానే ఇక్కడ తీసుకుంటున్నారు 43. 43 when principal diagonal elements are the eigen values, if it is a triangular matrix, scalar, diagonal, it is not possible in all cases. What is the lambda 1 plus lambda 2? Tell me, lambda 1 plus lambda 2 is how much? 7. Sum of the eigenvalues is the trace, lambda 1 plus lambda 2. Then what is the lambda 1 into lambda 2? Lambda 1 into lambda 2 is what? 12 minus 2, 10. Then both of them solve. Which value satisfies? 2 comma 5. Check 2 comma 5 satisfying or not. Lambda 1 into what is the lambda 2? 7 minus lambda 1 equal to 10. 7 lambda 1 minus lambda 1 square equal to 10. Lambda 1 square minus 7 lambda 1 plus 10 equal to 0. What are the lambda 1 values you are getting? 2 and 5. Lambda 1, 2 and 5. Lambda 1, 2. Then lambda 2 is what? Lambda 1, 2 అయితే lambda 2 ఎంత అవుతుందమ్మా? 5. Lambda 1 is 5. Lambda 2 is what? 2. In these two combinations, what is the least eigenvalue? Least eigenvalue is what? What is your answer? Least eigenvalue? 2 or 5? You are not responding. 2 or 5? 2. Least eigenvalue 2 is the answer. Lowest eigenvalue 2 is the answer. Yeah, coming to next, the eigenvalues of the hmm, eigenvalues of 10. This is what 10 minus 4, 18 minus 12, 6 minus 8 minus 6 8, 4 9 4 8. Tell me what is the answer? Easy question. What are the eigenvalues? You can guess the answer easily. First element is 10. Hello, 10 minus 4, 18 minus 12. What are the eigenvalues? What is the property we have to use? Sum of the eigenvalues is sum of eigenvalues is equals to trace. What is the trace of this? Trace is minus 2. Which sum is minus 2? 6 comma minus 8 is the answer. 6 comma minus 8 straight away. No need to do anything. 6 comma minus 8 is the correct answer. Clear? The last one is cleared. The matrix M minus 2, 2 minus 3, 2 1 6 has eigenvalues. Minus 3 has eigenvalues minus 3 5. An eigenvector an eigenvector an eigenvector corresponding to the eigenvector corresponding to eigenvalue 5, eigenvector corresponding to eigenvalue 5 is 1 2 minus 1 transpose. Then the one of the eigenvector of the matrix M cube, one of eigenvector of the matrix M cube. Can you guess what is the answer? 1 8 minus 1 transpose, 1 2 minus 1 transpose, 1 cube root 2 minus 1 transpose, 1 1 1 minus 1 transpose. Can you guess what is the answer? One eigenvalue. Observe here. Eigenvalues are given what? Eigenvalues of matrix M are minus 3, 5. One eigenvector of the matrix. Hello. M eigenvector. Eigenvalue is what? 5. Its corresponding eigenvector 1 2 minus 1 transpose. We have one property, remember. Hello. Very important property. If X is eigenvector of the A, X is eigenvector of the A, X is also eigenvector of A power n. X is eigenvector of the A. X is also eigenvector of A power n. ఇక్కడ చూడండి అమ్మా 1 2 minus 1 transpose is eigenvector of the, this is eigenvector of the what? M. Eigenvector of them corresponding to eigenvalue 5. What is eigenvector of M cube? M cube eigenvector same ఉంటుందా చెప్పండి. Is it same or not? X is eigenvector of the A. X is also eigenvector of what? A power n. Hello. Using this property, which one is correct answer? Using this property, which one is the correct answer? Think. X is eigenvector of the A. X is also eigenvector of A power n. ఈ సేమ్ వెక్టర్ ఉందా లేదా చూడండి. Do you have same vector or not? Same vector is there. Which is the correct answer? X is eigenvector of the A, then X is also eigenvector of the A power n. B option is the correct answer. Everybody understanding? B option. Yes. Coming to next, B option is the correct answer. మార్నింగ్ 3.5 hours నాన్ స్టాప్గా చెప్పానమ్మా. పిల్లలు ఇలా బయటకు వెళ్ళడం రావడం తక్కువ, వెళ్ళలేదు, ఎక్కువ శాతం వెళ్ళలేదు. మార్నింగ్ ఫుల్ రూమ్ నిండిపోయింది. 3.5 hours నాన్ స్టాప్. కొంచెం అవాయిడ్ చేయండి. స్టార్ట్ చేసి 1 hour కూడా అవ్వలే కదా. ఇలా 4:15 4:30 క్లోజ్ అవుతుంది మన సెషన్. వెళ్ళొద్దు అనట్లే కానీ ఫ్రీక్వెంట్గా అలా అవాయిడ్ చేయమని చెప్తున్నాను అంతే. యా, కమింగ్ టు నెక్స్ట్. What is this answer? If 1 0 minus 1, 1 0 minus 1 is the eigenvector of the following matrix. Then corresponding eigenvalue. Try all of you corresponding eigenvalue. Everyone try this. What's the answer? Easy question. Think cheyandi. After eigenvalues, eigenvectors, we have, what is our next topic? Cayley-Hamilton theorem. Cayley-Hamilton theorem. One more. Linear dependent and independent vectors. One 0 minus 1 is the eigenvector of the matrix 1 minus 1 0 minus 1 2 minus 1 1 minus 1 1. Then corresponding eigenvalue is, what is the corresponding eigenvalue? What is the solution here? Ax is equals to lambda x. 1 minus 1 0 minus 1 2 minus 1. This one ax is equals to lambda x. Okay. Yeah, multiply them. What is its multiplication here? First element ఏమొస్తుంది చెప్పండి అమ్మా. 1 1 0 0. First element is 1. Second element is what? Second element is minus 1 plus 1 0. Third element is what? 0 0 is a minus 1. Okay na? 1 0 minus 1 same vector repeated. Ax is equals to lambda x, same vector repeated. How much is the lambda value? ఇక్కడ lambda ఎంత ఉంది చెప్పండి అమ్మా. What is the lambda value here? 1 is the correct answer. Ax is equals to lambda x. Lambda value 1 is the correct answer. Lambda value 1 is the correct answer. Lambda value 1 is the correct answer. Yes. 1 వచ్చేస్తుంది కదా అందరికి. All of you got one answer? Yeah. Coming to next. Direct bit. What is the answer? Eigenvalues of skew symmetric matrix. Properties morning discussed. What are the eigenvalues of the skew symmetric matrix? Are either zeros or purely imaginary. Eigenvalues of skew symmetric. Eigenvalues of skew symmetric matrix are skew symmetric, skew Hermitian. Skew symmetric, skew Hermitian matrix. Eigenvalues of skew symmetric and skew Hermitian are what? Either zeros or purely imaginary. Direct bit. 5 seconds answer amma. Property. Properties and perfect chavutadi answer 5 seconds. Eigenvalues of symmetric matrix. Eigenvalues of symmetric matrix. Eigenvalues of symmetric matrix and Hermitian matrix. Eigenvalues of symmetric matrix and Hermitian matrix are always real. What is the answer? All are always real. That is a D option, always real. కాదమ్మా మీరు అందరు వెళ్ళిపోయేటట్టు క్లాస్ చెప్పడం ఎందుకు నాకు అర్థం కాదు. ఎందుకు వెళ్ళిపోతున్నారు మీరు? 4 o'clock వరకు క్లాస్ కదా, అట్లీస్ట్ 4 o'clock వరకు అని కూర్చోవాలి కదా. Yeah, if any that type of situation is there, okay, right? Otherwise, right, it's okay. Any reason, that's okay. Genuine reason. Yeah, coming to next. Yeah, what is the next question? Eigenvalues of skew symmetric matrix are either zeros or purely imaginary. Next to this question, tell me what is the answer? Hello. The trace and determinant of the matrix are -2 and -35 respectively. Its eigenvalues are. Can you guess what is the answer? Trace and determinant. Trace is what? -2, determinant is -35. What are the eigenvalues? What is the answer? చెప్పండి అమ్మా ఆన్సర్. ట్రేస్ ఎంత ఇక్కడ మనకి? ట్రేస్ ఈస్ what is the answer? Trace -2, determinant -35. Which answer is correct here? C option, -35. 5 seconds answer quickly. -35. C option is the correct answer. Very good. Most of you responded -7, -5. Very good. -7 plus 5 is -2. -7 into 5 is what? -35. Correct answer is C option is the correct answer. Very good. Yeah, this answer. What is the answer? చెప్పండి అమ్మా, ఈజీ. కోసం చెప్తున్నాం. మామూలుగా అయితే బయట వేరే క్లాసెస్లో కూడా ఎక్కువ స్ట్రెంత్ కూడా ఉంటుంది. ఏంటంటే ఈ 1 to KIET కరెక్ట్ మంచి KIET అనేది ఒక మంచి ఎగ్జామ్ మీకు లైఫ్కి. వేరే జాబ్లు అనేది ఈజీగా వస్తాయి. KIET త్రూ వచ్చే జాబ్ అనేది దానికి ఉండే రెస్పెక్ట్ ఉంటుంది. వాట్ ఇస్ ఆన్సర్? 3 and 6 are eigenvalues of A. Then eigenvalues of A transpose what? 3 and 6 same. 3 and 6. Eigenvalues of A and A transpose are same. 3 and 6. Eigenvalues of A are 1, 2, -3. Eigenvalues of A are 1, 2, -3. What are the eigenvalues of A square? చెప్పండమ్మా, eigenvalues of A square. What are the eigenvalues of A square? 149. 149 are the eigenvalues of A square. Huh? What happened, bro? What are the eigenvalues of A square? 149. Yes or no? Next. These are all the questions on eigenvalues and eigenvectors. We have one more Cayley-Hamilton theorem also. Chudandamma. Matrix A is given. Matrix A is given 2503. A power 4 minus 5A cube 6A square plus 2I. E determinant, what is the determinant value of this? Is the recent GATE paper. Matrix A is given 2503. What is the determinant value of A power 4 minus 5A cube plus 6A square plus 2I? Can you guess what is the answer? What are the eigenvalues of A? Eigenvalues of A చెప్పండమ్మా. What is the eigenvalues of A? 2 and 3. 2 and 3 నే కదా. You are not responding. 2 and 3 na? Yes. Then what are the eigenvalues of A power 4? A power 4 చెప్పండమ్మా. What are the eigenvalues of A power 4? 16 and 81. Eigenvalues of minus 5A cube. చెప్పండమ్మా 5A cube. A is what here? A cube means 8. Minus 40. 27 into minus 5. How much? ఎంత మీది 27. A cube అంటే 27 into minus 5. 27 minus 5. 110 na? 27 into 5. 110 na? How much amma? 135. Minus 135. 6A square. Hello. Eigenvalues of 6A square is what? A square is 4. 24. 9. 54. 2I eigenvalues. What are the 2I eigenvalues? 2 and 2. Then all eigenvalues are what here? 16 minus 40, 24. This is 2. 0. This is also 2. What are the overall eigenvalues we got? 2 comma 2. Yes or no? What are the overall eigenvalues? 2 comma 2. Then what is the determinant here? He is asking determinant. Determinant. Let us take this is B. Overall it is B. What is the determinant of the B? 2 into 2? 4 is the answer. 2 into 2, 4 is the answer. Very good. Then next, let us move to Cayley. This question is clear now? 2 marks bit. Let us go to our eigenvalues, eigenvectors. One big topic completed. Out of all, what is the big topic is? First one, types of matrices. In the morning cheppanu, types of matrices, 30 different types of matrices. After that, we discussed about the rank, very important. Then system of linear equations. Then eigenvalues and eigenvectors. Compulsory type of questions. DA students ఎవరైతే ఉన్నారో data science, artificial intelligence, linear algebra 10 to 12 marks. Linear algebra. CSE students 3 marks. మరి DA students 10 to 12 వర్కౌట్. కొంచెం వర్క్ చేయండి. ఒక డ్రీమ్ పెట్టుకోండి ఐఐటిలో ఎంటర్ అవ్వాలని. చూసినారు కదా రీసెంట్ సంజు శాంసన్ ఎంత కష్టపడ్డాడు పాపం. మీరు కూడా అట్లా ఒక ఫైర్ రావాలి మీలో కూడా. ఒక ఫైర్ రావాలి. ఎందుకంటే బాబు ఇన్ని రోజులు మీరు ఒక ఐఐటి డ్రీమ్ పెట్టుకుంటే కొంతమంది బీటెక్ ఐఐటి మిస్ అయింది, మీకు మిస్ అయింది. మరి ఈసారైనా ఎంటెక్ ఐఐటి ఒక ఫైర్ తోటి ఎంటర్ అవ్వాలి, అది ఒకటి పెట్టుకోవాలి. మీరు ఏ కాలేజీలో చదువుతున్నది కూడా, అది కూడా కాలేజ్ ఇంపార్టెంటే. కాకపోతే కొంతమంది స్టూడెంట్స్ ఏ పెద్ద ఇంకా యూనివర్సిటీ చదివే వాళ్ళకే వస్తుంది, అట్లాంటిది ఏం లేదు. యూనివర్సిటీలో చదివే వాళ్ళు కూడా డిస్క్వాలిఫై అయిన వాళ్ళు ఉన్నారు. నార్మల్ కాలేజ్, వెరీ యావరేజ్ కాలేజ్ చదివిన వాడు కూడా ఫస్ట్ ర్యాంక్ వచ్చిన వాళ్ళు ఉన్నారు. గేటు ఇట కాలేజీకి లింకులు పెట్టుకోవద్దు, మీరు వర్క్ చేయండి, మంచి ర్యాంక్ వస్తుంది. కేలీ హెమిల్టన్ థీరం, రైట్ డౌన్ స్టేట్మెంట్. కేలీ హెమిల్టన్ థీరం. కేలీ హెమిల్టన్ థీరం. కేలీ హెమిల్టన్ థీరం. లాస్ట్ టాపిక్ నా. కేలీ హెమిల్టన్ థీరం. దీని తర్వాత ఇంకొక స్మాల్ టాపిక్ ఉంది, లీనియర్ డిపెండెంట్ ఇండిపెండెంట్. రైట్ డౌన్. కేలీ హెమిల్టన్ థీరం స్టేట్మెంట్. Every square matrix satisfies Cayley Hamilton theorem statement. Every square matrix satisfies its own characteristic equation. Write down. Cayley Hamilton theorem. Every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. If you take the example characteristic equation lambda square minus 3 lambda plus 2 equal to 0. Lambda square minus 3 lambda plus 2 equal to 0. As per Cayley Hamilton theorem, what happens here? You can replace lambda with the a. A square minus 3a plus 2i is equals to 0. A square minus 3a plus 2i is equals to 0. From this you can write 2i. 2i is equals to 3a minus a square. వినండమ్మా. What is the purpose of the Cayley Hamilton theorem? మీరు బీటెక్ ఫస్ట్ ఇయర్లో చదివారా? కేలీ హెమిల్టన్ థీరం చదివారు కదా. వాట్ ఇస్ ద పర్పస్? ఎవ్రీ స్క్వేర్ మ్యాట్రిక్స్ సాటిస్ఫైస్ ఇట్స్ ఓన్ క్యారెక్టరిస్టిక్ ఈక్వేషన్. 2i is equals to 3a minus a square. If you multiply both the side with a inverse, 2i a inverse is equals to 3a a inverse minus a square into a inverse. 2 into a inverse is equals to 3i minus a. A inverse is equals to what? 1 by 2 into 3i minus a. So that way we are getting the a inverse is 1 by 2 into 3i minus a. And from here what is the a square? A square is equals to 3a minus 2i. A square equal to 3a minus 2i. If you multiply both the side with the a cube equal to 3a square minus 2a. 3a square minus 2a. A cube equal to 3 into what is the a square here? 3a minus 2i minus 2a. 9a minus 2a, 7a minus 6i. చూడండి ఇక్కడ a cube is equals to ఏమొచ్చింది మనకి? 7a minus 6i. A square is 3a minus 2i, a cube is 7a minus 6i. Again if you multiply with the a, what is the result here? A power 4 equal to 7a square minus 6a. A power 4 is equals to 7 into, what is a square here? A square 3a minus 2i minus 6a. What is the result? 21a minus 6a. 15a minus 14i. Okay, a power 4 is equals to 15a minus 14i. Yeah. Write down what is the purpose of the Cayley Hamilton theorem. చూడండి, first we calculated a inverse. A inverse in terms of a square also in terms of a cube in terms of a power 4 also in terms of a. Write down. Cayley Hamilton theorem is useful Cayley-Hamilton theorem is useful. After copying this, note down these equations. So note down all these equations. Now, yeah, just write down Cayley-Hamilton theorem is useful. Cayley-Hamilton theorem is useful to find highest powers of A. Cayley-Hamilton theorem is useful to find highest powers of A. Cayley-Hamilton theorem is useful to find highest powers of the A and also A inverse. Highest powers of A and also A inverse. A inverse. You see here A inverse we calculated in terms of A and highest powers of A also in terms of the A. Clear, na? Right. Let us do one question. The eigenvalues of A are 1 and 3. Eigenvalues of A are 1 and 3. Then A cube is equals to what? What is A cube? Option A, 12A minus 13I. Option B, 13A minus 12I. Option C, 12 into A minus I. Option D, 13 into A minus I. That is the question. Eigenvalues of the matrix A are given. What is A cube? Can you guess what is the answer? Cheppandamma. ఏమొస్తుంది ఆన్సర్ చెప్పండి. Lambda 1 is 1, lambda 2 is 3. What is the characteristic equation? Lambda minus 1 into lambda minus 3 equal to 0. From this we have to calculate characteristic equation minus 4 lambda plus 3 equal to 0. Now we got the characteristic equation. Then what you can do after this? After characteristic equation, A square, replace lambda with the A. What is the statement of Cayley-Hamilton theorem? Every square matrix satisfies its own characteristic equation. As per that statement, what is the answer? Amma cheppandi ikkada em vastundi? A square minus 4A plus 3I. A square is equals to what? 4A minus 3I. A square is 4A minus 3I. A cube. What is A cube? 4A square. A cube is what? 4A square minus 3A. 4 into, what is A square again? A square is 4A minus 3I minus 3A. 16A minus 3A. 13A minus 12y. 13A minus 12y. Option B is the correct answer. 13A minus 12y. Option B is the correct answer. It's clear now. Whenever they are giving this type of questions, we have to confirm it belongs to Cayley-Hamilton theorem. Okay. Next. A is equals to ABCD. A is equals to ABCD. If A plus D is equals to AD minus BC is equals to 1, A cube is equals to what? That is our question. A cube is also recent GATE paper, GATE and ESE. They are all repeated in GATE and ESE also. What are the options are given? A minus I, A plus I, minus I, null matrix. What is the answer? What is the answer? Yes. Try. What is the answer here? Determinant of A minus lambda equal to 0. Determinant of A minus lambda B C D minus lambda that equal to 0. A minus lambda into D minus lambda minus BC is equals to 0. Simplify. చూడండి మీకు ఇట్లాంటి క్వశ్చన్ చాలాసార్లు రిపీట్ అయింది చూడండి గేట్లో ఈఎస్సిలో రిపీట్ అయింది గేట్ ఎగ్జామ్ ఈఎస్సి మీకు ఈఎస్సి ఎగ్జామ్ లేదు ఉందా సిఎస్సి బ్రాంచెస్ నాట్ హ్యావింగ్ ఈఎస్సి ఈసీఈ ఎలక్ట్రికల్ మెకానికల్ సివిల్ దే ఆర్ హ్యావింగ్ ఈఎస్సి engineering service exam. All of you know top. What is the top job in the technical side is ESC exam. Okay. Multiply them AD. This is AD minus lambda into A plus D minus BC. One more is what lambda square also there. Now lambda square equal to 0. AD minus BC. These two terms take together. AD minus BC together. AD minus BC together minus of lambda into A plus D plus lambda square equal to 0. It is given what? A plus D is given what? A plus D is given 1. AD minus BC is also 1 minus lambda plus lambda square equal to 0. Now apply Cayley-Hamilton theorem. As per Cayley-Hamilton theorem, 1 becomes what here? I minus A plus A square equal to null matrix. From here, what is the A square? A square equal to A minus I. A square is A minus I. A square is A minus I. Then what is A cube? A cube is equals to what? A square minus A. A cube is A square minus A. What is A square here? A minus I minus A. These two are cancelled. What is A cube answer we got? Minus I is the correct answer. A cube minus I. A cube is equals to minus I is the correct answer. A cube is minus I. Understanding na? All of you are understanding clear? Cayley-Hamilton theorem. Identifying question related to Cayley-Hamilton theorem also important. Yesterday and today, what are the topics you have done till now? Tell me. Types of matrices, 30 different types. Rank, LU decomposition, LU, lower triangular and upper triangular. Then after the rank, LU decomposition, system of linear equations, eigenvalues and eigenvectors, Cayley-Hamilton theorem. Next question. The constant term of characteristic polynomial. It's clear na? No confusion? All of you copied? Yeah. The constant term. The constant term of the constant term of characteristic polynomial. Constant term of the characteristic polynomial of the matrix. Characteristic polynomial of the matrix. Characteristic polynomial of the matrix. What is the matrix here? 1, 2, 6, 5. 1, 2, 6, 5. Minus 1, 3, 2. Minus 5. 2, 4. 12, 10. 3 minus 2. 1 minus 4. Hello, that is our question. What is the characteristic polynomial of the matrix? Characteristic polynomial of the matrix. 1, 2, 6, 5. 6 different, 5 different. Characteristic polynomial of the matrix. Constant term of the characteristic polynomial of the matrix. Option A 0, B 1, C trace of A, D 2. What is the correct answer? Constant term of the characteristic polynomial. Observe. Constant term of the characteristic polynomial. What type of matrix it is? Hello. If you observe that first row, third row are proportional. 1, 2, 6, 5, 1, 2, 6, 5. Yes or no? First row, third row are proportional. Yes or no? First row and third row are proportional. What happens? Determinant value 0. If two rows are the same or proportional, determinant vanishes. Determinant value 0. చూడండి అమ్మా, determinant value 0. What is the answer? Can you guess? Constant term of the characteristic polynomial. చాలా interesting question వినండి. If determinant is 0, what happens? Determinant is 0. All of you confirmed why determinant is 0. First row and third row are proportional. Determinant value 0. Determinant is 0. If determinant is 0, if determinant is 0, one of the eigenvalue must be 0. One of eigenvalue must be 0. Yes or no? One of the eigenvalue must be 0. If one of the eigenvalue is 0, what happens here? Because of this is a 4 by 4 matrix, 4 by 4 matrix, you will get the fourth degree polynomial. Fourth degree polynomial. Some example you are taking lambda power 4, 6 lambda cube, 11 lambda square. ఒక ఎగ్జాంపుల్ తీసుకుంటున్నాను చూడండి, వినండి, చాలా ఇంపార్టెంట్ ఇంట్రెస్టింగ్ క్వశ్చన్. లాంబ్డా వాల్యూ ఏమవ్వాలమ్మ ఇక్కడ? లాంబ్డా వాల్యూ we should get the 0. When you get the lambda value is 0, lambda common. If there is no constant term, this is very important point. If there is no constant term, then only you will get the lambda common. Some example I am taking here. Hello, don't think that this is the original equation for that. Some example. Lambda value 0 కావాలంటే ఇక్కడ కాన్స్టెంట్ టర్మ్ ఉండాలా లేదా చెప్పండి అమ్మా. ఉండకూడదు కదా? No constant term, then only lambda it comes common outside. Lambda equal to 0. What is our answer? What is the question is asking? Constant term of the characteristic polynomial of the matrix. 0 is the answer. Constant term of the characteristic polynomial. You see here, if the equation is like this, then only you get the lambda common outside. అర్థమైంది కదా? Is it clear? This side voice. Lambda common ఎందుకు వచ్చిందమ్మా? No constant term. ఏమో అర్థమైంది కదమ్మా గర్ల్స్? Lambda common ఎందుకు వచ్చింది ఇక్కడ? There is no constant term. Why no constant term? One eigenvalue it must be 0. One eigenvalue it must be 0. What is the constant term of the characteristic polynomial? 0 is the correct answer. This is also a previous gate question, recent papers. Next. It's clear to all of you? 0 is the answer. Next. If A is equals to 1 0 0 0 1 1 0 minus 2 4 1 0 0 0 1 1 0 minus 2 4 6A inverse 6A inverse is equals to A square plus CA plus DI. What are the C and D values? What are the C and D values? Option A, minus 6 comma 11. Option B, minus 11 comma 6. Option C, 11 comma 6. Option D, 6 comma 11. What is your correct answer? First of all, we have to confirm it is related to Cayley-Milton theorem because of A inverse expressed in terms of A square and D. What is the Cayley-Milton theorem? First, characteristic polynomial. First, we should get the characteristic polynomial. Determinant of A minus lambda equal to 0. 1 minus lambda 0 0 0. 1 minus lambda 1 0 minus 2. 4 minus lambda det equal to 0. Det equal to 0. We are finding the characteristic polynomial. Characteristic polynomial. What is the result of this one? 1 minus lambda 1 minus lambda into 4 minus lambda plus 2 equal to 0. Multiply them. 1 minus lambda into, this is 4, minus 4 lambda minus 5 lambda plus lambda square plus 2 equal to 0. 4 minus 4 lambda minus 5 lambda plus lambda square plus 2 equal to 0. Multiply them. 1 minus lambda into lambda square minus 5 lambda plus 6 equal to 0. చూడండి అమ్మా రెండింటిని మల్టిప్లై చేసి సింప్లిఫై చేయండి. వాట్ ఇస్ ద రిజల్ట్? లాంబ్డా స్క్వేర్ మైనస్ 5 లాంబ్డా ప్లస్ 6 మైనస్ లాంబ్డా క్యూబ్ ప్లస్ 5 లాంబ్డా స్క్వేర్ మైనస్ 6 లాంబ్డా ఈక్వల్ టు 0. What is its further simplification? Minus lambda cube plus 6 lambda square minus 6 lambda minus 11 lambda plus 6 equal to 0. Lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. What is the name of this equation? It is a characteristic polynomial. Now we got characteristic polynomial. For this you apply the Cayley-Hamilton theorem. For this you apply the Cayley-Hamilton theorem. What is the Cayley-Hamilton theorem statement? Every square matrix satisfies its own characteristic equation. What is the result we are going to get here? A cube minus 6a square plus 11a minus 6i is equals to 0. From this we want 6i. Subject the 6i. 6i is equals to a cube. 6i is equals to a cube minus 6a square plus 11a. If you multiply both the side with a inverse, both the side a inverse toti multiply cheyandi. What is the answer? 6 into a inverse is equals to a square minus 6a plus 11i. That is the answer. What are the C and D values? C and D comparison cheyandi amma. What is the C and D? 6a inverse a square. What is the C value? C value minus 6. C value minus 6. D value 11. Which option? A option. Minus 6 comma 11 is the answer. Correct na? C comma. Means we have to confirm it is related to Haley-Hamilton theorem question. Haley-Hamilton theorem. Minus 6 comma 11 is the correct answer. So that is also a previous gate question. Haley-Hamilton theorem. Yes. Clear na? One more very interesting question. We have 2 marks bit. 2 marks bit recent paper. Very interesting question. Let's take this one completed. Clear na? Yes. A is equals to 1423. A is 1423. The expression a power 4 minus 4 a power 5. This is a power 5 minus 4 a power 4 minus 7 a cube plus 11 a square minus a minus 10I is equals to what? This is our question is given. Is equal to option a square plus a plus 5y. Option B, a plus. Option C, a square plus 5y. Option D, a square plus 2a plus 6I. This is our one interesting question, 2 marks bit. 2 marks bit. So whenever you are observing this type of question, you have to confirm it is a Cayley-Hamilton theorem. Cayley-Hamilton theorem. First of all, write what is the characteristic polynomial. Determinant of a minus lambda equal to 0. 1 minus lambda 4, 2. 3 minus lambda that equal to 0. 1 minus lambda into 3 minus lambda minus 8 is equal to 0. What is its simplification here? 3 minus 3 lambda minus 4 lambda minus 3 lambda minus lambda plus lambda square minus 8 equal to 0. Lambda square minus 4 lambda minus 5 equal to 0. Up to here clear to all of you? 2 marks bit. Very interesting question. Please concentrate. Now, Cayley-Hamilton theorem. Apply Cayley-Hamilton theorem. What is the result here? A square minus 4a minus 5y equal to 0. Now, this term, this is what? Fifth degree is there. Fifth degree we have to simplify like to second degree and first degree. Fifth degree expression ni manamu second degree గాని first degree లోకి తీసుకురావాలి. In these three terms, what is the common? In these three terms, a cube is common. A cube is common. Then straight away write this. Straight away write a square minus 4a minus 5y. Then adjust the terms. Adjust the terms. A power 5 is there. Please concentrate here. A cube into a square is what? A power 5 minus 4a power 4 minus 5a cube. Minus 5a cube. One more minus 2a cube is pending. Yes or no? Yeah. All of you are concentrating. Minus 2a cube is pending here. Minus 5a cube is completed. Minus 2a cube is pending. 11a square minus a minus 10I. What is the result of this one? It is a null matrix. A cube null matrix is, this result is 0. Minus 2a cube, 11a square minus a minus 10I. ఇక్కడ చూడండి అమ్మా మళ్ళీ ఏం చేస్తున్నాం మనము ఇదే టర్మ్ లోకి తీసుకురావాలి. We have to bring into this term. For that I am taking the minus 2a is common. Minus 2a is common. A square minus 4a minus 5y. Now adjust the terms. Minus 2a cube is there. Observe. Minus 2a cube is there. మైనస్ ఇంటూ ప్లస్ మైనస్ ఆ మైనస్ ప్లస్ ఎంత ఉందాం ఇక్కడ 8a square, but here is the 11a square is there. 8a square completed means what is the term we should get? 8a square అంటే ఇక్కడ 11a square ఉంది కదా మనకి, ఎంత రావాలి ఇక్కడ? 3a square. 3a square, this is what? 10i. చూడండి అమ్మ ఇక్కడ 10i ఉంది కదా, 10i, but here is what? Minus a. This is 10a is there, but minus a is there. Minus 11a. See here, yes or no? Plus 10a minus 11a minus a minus 10i. This is 0. What is the result we got? 3a square minus 11a minus 10i. Is this there in that answer? Quadratic undama లేదు కదా? You are not responding, yes or no? Which options are wrong? A and D wrong. A, D, C are wrong. A wrong, C wrong, D wrong. What's the left? Definitely B. B. Whether you will get the B or not, also you check 3 into. What is A square here? A square is what here? 4a plus 5i minus 11a minus 10i. This is what? 12a minus 11a. A plus 15i minus a plus 5i is the correct answer. B option is correct. This type of questions are 2 marks bits. The question ఏం చేస్తున్నాం మనం? highest degree term, a power highest degrees, we are slowly reducing into the least degrees, a square and a. ఏం టెన్షన్ పడాల్సిన అవసరం లేదు. ఫస్ట్ we have to confirm it is related to Cayley-Hamilton theorem, slowly reducing into the single powers. This type of questions 2 marks bits. ఇక్కడ చూడండి, నేను పర్పస్గా ఇది రాసేసినాక మిగతా సింప్లిఫై చేశాను చూడండి. ఇన్ బోత్ ద కేసెస్ beginning we have written a square minus 4a minus 5i, further simplified. Yeah, anybody confusion is there? All of your understanding? Yes. Hope everyone understanding linear algebra. చూడాలమ్మా నెక్స్ట్ గేట్ ఎగ్జామ్లో మన కాలేజ్ నుంచి సింగిల్ డిజిట్ ర్యాంక్స్ ఎంతమందికి వస్తున్నది? ఒకటి బాబు, చిన్న సజెషన్, మన గురించి మనం మాట్లాడుకునేటప్పుడు వినండి, ఒకటి ఫ్యూచర్లో కూడా మన గురించి మనం మాట్లాడుకోవడం ముందు మనం నవ్వడం ఆపాలి మన మీద. వేరే వాడు జోకులు వేసినప్పుడు కూడా అలో చేయనివద్దు కామెడీ. ఎందుకంటే మనము ఒకటి గుర్తుపెట్టుకోండి బాబు, లైఫ్లో హీరో లాగా ఉండాలి, కామెడియన్ లాగా కాదు. వేరే వాడు జోకులు వేసేటప్పుడు ఆ జోకులు పడి మనం కామెడియన్ కాకూడదు. అర్థమవుతుంది కదా? ఫ్రెండ్ సర్కిల్ వారికి ఒక ఇద్దరు ముగ్గురు మొత్తం లైఫ్ లాంగ్ కామెడియన్ అయిన అనుకోండి, ఎట్లా ఉంటుంది? Write down next one small topic, linear dependent and independent of the vectors. One continuation, linear dependent, independent. Write down linear dependent and independent of the vectors. Write down. Side heading, linear dependent and independent of the vectors. Last topic in this. Side heading is what? Linear dependent and independent of the vectors. Two vectors are said to be linearly dependent. Two vectors are said to be linearly dependent. Two vectors are said to be linearly dependent if one vector is expressed in terms of another vector. If one vector is expressed in terms of the another vector. Two vectors are said to be linearly dependent if one vector is expressed in terms of another vector. Okay. See, till now we have discussed what are the topics, types of matrices, types of matrices, different 30 different type, very important. Second rank, third LU decomposition also. We have discussed LU decomposition, third, fourth, system of linear equations. System of linear equations. Non-homogeneous and homogeneous. Fifth one, characteristic matrix. Characteristic matrix. Characteristic equation. Characteristic matrix, characteristic equation. Sixth, eigenvalues and eigenvectors. Eigenvalues, eigenvectors also. Seventh, what is the seventh topic we discussed? Cayley-Hamilton theorem. Cayley-Hamilton theorem. Cayley-Hamilton theorem. Cayley-Hamilton theorem. Now last small topic, linear dependent and independent. Linear dependent and independent of the vectors. Linear dependent and independent of the vectors. These are the total 8 subtopics you have to study in depth from the linear algebra. Every topic is very important. Linear dependent. Linear dependent of vectors. So vectors means here whatever we discussed eigenvectors also by. If you take the vector x 1, 2, 3, this is a vector, column vector. This is called column vector. If you write the vector like this 1, 2, 3, row vector, column vector, row vector. Column vector is also called column matrix. Column vector, column matrix, row vector, row matrix, row vector, row matrix. What is the definition of the linearly dependent vectors? Write down. Two vectors are said to be linearly dependent. One vector, if one vector can be expressed, one vector can be expressed in terms of the another vector. Two vectors are said to be linearly dependent. If one vector can be expressed in terms of another vector. You see here x2 is equals to what? x2 is 2x1. Yes or no? x2 is equals to 2x1. Is it possible x2 equal to 2x1? Yes. x2 equal to 2x1. If you write x2 in terms of x1, then it is called linearly dependent. Otherwise, independent. Otherwise, independent. If the determinant formed by the two vectors is 0, what is the determinant formed by 1, 2, 2, 4? Check. What is the determinant formed by 1, 2, 2, 4? 0 or not? 0. Hello. If the determinant formed by the vectors is 0, second definition for the linearly dependent, write down. Second definition for linearly dependent. If the determinant formed by the vectors is 0, if the determinant formed by the vectors is 0, then the vectors are said to be linearly dependent. If the determinant formed by the vectors is 0, then the vectors are said to be linearly dependent. Otherwise independent. Otherwise independent. See here, this determinant value is 0, therefore you can say the vectors are linearly dependent. Yes, coming to a1 x1 plus a2 x2 plus a3 x3 plus so on an xn equal to 0. How many vectors are there in here? N vectors are there. Please concentrate. This definition is very important. a1 x1 plus a2 x2 plus so on an xn equal to 0. For all a1 equal to a2 is equals to a3 and so on. an is equals to 0. For all a1, a2, a3, an equal to 0. Then now tell me what is your answer. If a1, a2, a3, an all are zeros, what is your answer? Vectors are linearly dependent or independent? No a1. There is no a1, no a2, no a3, no an. If all a1, a2, 3, an all are zeros, will you find any relation between the vectors? You are not responding. a1 0, a2 0, a3 0, an all are zeros. If all are zeros, is there any relation between the vectors? No relation. Means what is the nature of the vectors there? They are said to be linearly independent. Linearly independent. Very, very important definition. a1 x1 plus a2 x2 plus a3 x3 plus so on an xn equal to 0. For all a1 equal to a2, an equal to 0, then all vectors are said to be, all vectors x1, x2, x3, so on, xn are said to be linearly dependent or independent in this condition. Linearly, you are not responding. Dependent or independent? Independent. చూడండి అమ్మ, మీరు ఏం కన్ఫ్యూజ్ అవ్వద్దు, డెఫినేషన్ బై హార్ట్ చేయొద్దు. నేనేం చెప్తున్నాను ఇక్కడ, a1 a2 a3 an ఇవన్నీ జీరోసే. If all a1 a2 a3 an are zeros, will you find any relation between x1 x2 x3 xn? No relation. That means x1 x2 x3 xn, they are all said to be linearly independent. Linearly independent. Next, linearly dependent definition is what? If sum of a's, a numbers, a1, a2, a3, If sum of the A's are all, sum of A's are all, are non-zeros. This is very important definition. Listen. A1, A2, A3, An, all are non-zeros. All are non-zeros means what? Linearly dependent or independent? When I said A1, A2, A3, An, all are zeros, what is the answer we discussed? They are linearly independent. If all are non-zeros means what? They are linearly dependent or not? Linearly dependent. All. What is the definition is saying? Sum of them. Sum of A1, A2, 3, An. Sum of them are all. Sum of them. If sum of them are all are non-zeros, then x1, x2, x3, xn are said to be linearly dependent. These two definitions are very, very important. Linearly independent, linearly dependent. Everyone understanding? These two definitions are very important. Yeah, some example questions we'll see. Let us see some examples, linearly dependent and independent. Yes. Try this question. X1 is equals to 1, 2, 2. X2 is equals to 2, 1 minus 2. X3 is equals to 2 minus 2, 1. Yeah, try this question all of you. Linearly dependent or independent? Try all of you. These three vectors are dependent or independent? What is the condition to check the dependent or independent? Just find out the determinant formed by the vectors. Yeah, what is the answer? Linearly dependent or independent? What is your answer? If the determinant formed by them, x1, x2, x3, determinant formed by them, you check 1, 2, 2, 2, 1 minus 2, 2 minus 2, 1. What is the determinant value of this? Yesterday I discussed one shortcut for the determinant. Observe. Go through that shortcut of the determinant also. 1 into 1 minus 4 minus 2 into 2 plus 4 plus 2 into minus 4 minus 2. This is minus 3 minus 12 minus 12 minus 25 not equal to 0. Determinant not equal to 0. If determinant 0, what is the answer? Linearly dependent. Now what is its answer? All are linearly independent. Three vectors are linearly independent. Yes or no? Yeah. If I'll ask you here, A1 x1, A2 x2, A3 x3 equal to 0. What are the A1, A2, A3? Can you guess? A1 x1 plus A2 x2 plus A3 x3 equal to 0. What are the A1, A2, A3? For all, A1 equal to all are zeros only. If there are linearly independent means what are the A1, A2, A3? All are zeros. You are not responding. Correct or not? Linearly independent means what are the A1, A2, A3? All are zeros. Means you will not find any relation between them. How many vectors are linearly independent? Number of linearly independent vectors. Number of linearly independent vectors. How many linearly independent vectors? 3. 3 vectors are linearly independent. This 3 is called dimension. Hello. One more definition. Remember dimension. What is the dimension? Dimension. Please note down the definition. Dimension. Hello. What is the dimension? Number of linearly independent vectors. Number of linearly independent vectors is called dimension. Number of linearly independent vectors is called dimension. Number of linearly independent. Basis. What is the basis definition? Basis. Basis definition. Set of linearly independent vectors. Set of linearly independent vectors. Set of linearly. You keep them, all of them in the set form. Yes, these words also very important. Yeah, బాబు వినండి. లాస్ట్ టాపిక్ మీరు బీటెక్లో చదివారో లేదో తెలియదు. Is this topic is there? Linear dependent, independent. Yeah. What is the definition of linearly dependent? One vector in terms of the other vectors, then they are linearly dependent. Otherwise, independent. Set of linearly independent vectors is called dimension. Sorry, number of linearly independent dimension. If you are keeping them into the set form, it is called the basis. These definitions also. Let us take one more question here. Yes. X1 is 1 to 1. X2 is X6X. X3 is 342. Are linearly dependent. Note down this question. 3 vectors are linearly dependent. What is the X value? This type of questions frequently they are asking. Three vectors are linearly dependent. What are the X values? This type of questions are famous. Frequently they are asking in the GATE exam and ESE. Are linearly dependent. What the question is asking? Three vectors are linearly dependent. Then what is the value of the X? What is the condition for the linearly dependent? Linearly dependent condition is what? Determinant formed by them is 0. Find out the determinant equate to 0. Find out the determinant equate to 0. 1 to 1 x6x 342 det equate to 0. Find out this x value. Det equal to 0. Different options are given. Option A 0, B 1, C 2, D 3. Hello. Which value satisfies? Embabu. Find out the x value. Yes. How much is the x value here? What is the x value here? Equate the determinant to 0. How much is the x value? 3. X equal to 3 is the correct answer. Equate the determinant to 0. X equal to 3. If x is equals to 3, what happens here? 1, 3. This is what? 1, 3, 3. This is also 1, 3, 2. 1, 3, 2. Determinant becomes 0. Because of these two rows are the same, determinant becomes 0. 3 is the correct answer. For 3 is equals to determinant value 0. If you put x value 3, 2 rows becomes, yeah. So this type of questions also very important. What is the dimension? Dimension means number of linearly independent basis is what? Set of linearly independent vectors. Dimension and basis. Next. So try the next question. 1, 2, 3. 1, 2, 3. 3 minus 2, 11. 1 minus 6, 5. What is its answer? 3 vectors. Linearly dependent or independent? X1 is 1, 2, 3. X2 is 3 minus 2, 11. X3 is 1 minus 6, 5. They are linearly dependent or independent? Try all of you. Linearly dependent or independent? Try all of you. What is the determinant value? Determinant is 0 or not equal to 0? సెషన్ అయిపోతుంది వస్తావా yes what is the determinant formed by them 1 2 3 3 minus 2 11 1 minus 6 5 how much is the determinant value got what is the determinant value 0 or not equal to 0 1 into minus 10 plus 66 minus 2 into 15 minus 11 plus 3 into minus 18 plus 2 56 minus 6 minus 48 0 determinant formed by the three vectors 0 then the vectors are said to be what linearly dependent or independent linearly dependent and number of linearly independent vectors number of linearly independent hello how many are linearly independent vectors the rank of this matrix how much is the rank of this matrix is 2 rank of this matrix will not be 3 rank of the matrix is 2 number of linearly independent vectors is equals to 2 that is called dimension hello dimension what is the dimension number of linearly independent vectors what is the basis here basis is equals to set of the linearly independent vectors 1 2 3 3 minus 2 11 3 minus 2 11 1 minus 6 5 1, 2, 3, 1 minus 6, 5. These are the bases. What is the basis? Set of linearly independent. Last question is what? 3 vectors are linearly independent. But in this question, 2 vectors are linearly independent. What is the answer? Dimension is 2. Basis is a set of 2 linearly independent vectors. Yes. So whenever they are linearly independent, you will find the relation between them. So totally, what are the topics we have? Types of matrices, rank, system of linear equation, characteristic matrix, characteristic equation, eigenvalues, eigenvector, Cayley-Hamilton theorem, LU, decomposition, linear dependent and independent. Okay? So try some more questions from the previous papers. Okay. So with this, we are going to close the session. Completed. Try work out from some more questions. Any confusions, bring. Okay, thank you. Prepare well. Wait, wait. See, sit down, sit down. Say, I will give that 5-10 minutes revision, whatever completed. Just sit down. Wait, wait. Hello. Come, stop discussions. Whatever we discussed, 5 minutes revision. See, in the types of matrices, whenever we discussed, what is row matrix, whose order is 1 by n. Yes. Rectangular matrix, what is the definition? M is not equal to n. rectangular square matrix is M equal to N. What is that trace? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 plus 5 plus 9. It's called the principal diagonal elements. We have discussed properties of the trace also. Trace properties. Then upper triangular matrix, lower triangular, scalar, diagonal matrix, unit matrix. What is that transpose matrix properties? A transpose, whole transpose, AB whole transpose. All properties remember A KA whole transpose, K into A transpose. All these properties of the transpose. What is a symmetric matrix, Q symmetric matrix, orthogonal conditions, some examples, types of matrices. Rank also two methods, determinant and echelon form. So totally 8 subtopics are there. Concentrate all the topics.